Hello students, so we're now going to start our next section, which is section 6.3, and section 6.3 is entitled The Least Common Denominator. The Least Common Denominator. Okay, we're working in section 6.3 now, and I'm going to work at Elmo for the rest of the section. So let's take a look at my first example. We're going to find the least common denominator. And the first example, A, says let's find the least common denominator of 1 over 8 and 3 over 10x. So perhaps we want to add these fractions or subtract them. The first step is to always get a common denominator. So how are we going to do this? Well, the first thing we're going to do, step number 1, is you want to factor each denominator into prime factors. The first step, whenever you find a least common denominator, is to factor each denominator into prime factors. So let's do that. Let's look at our denominators here. Our first denominator is 8. 8 factored into prime factors. Remember what prime means. Prime means broken down as far as possible, or not divisible by any number but 1. So the prime factors of 8 is actually 2 times 2 times 2. Check that out. 2 times 2 is 4. 4 times 2 is 8. I have broken 8 down, or factored 8 into prime factors. Now we're going to do the same thing with 10x. 10x can be written as 5 times 2 times x. And again, that's broken down as far as possible into prime factors. That is the first step. Whenever you find a least common denominator, you want to factor each denominator into prime factors. Now, what do you do with it after that? Well, let's move up and let's look at step number 2. Step number 2 says, list each different factor the greatest number of times it appears in any denominator. Let me repeat. That says list each different factor the greatest number of times it appears in any denominator. So what does that mean? Well, that means take each factor. We'll start with the factor 2. What is the greatest number of times that 2 appears in either of those two factors? Well, let's see, or either of those two denominators. Well, here 2 appears 3 times. And here 2 appears once. Clearly, 3 times is greater than once, and therefore I'm going to list 3 2's, because that's the greatest number of times I see 2 appearing in either of the denominators. Let's move along to the next factor, which is 5. Well, 5 does not appear in the top, but it does appear here, and it appears here once, and that's the most you see 5 appearing, so we'll list 5 once. And finally, the last factor that you have to worry about is x. X does not appear here, but it does appear here, so again, the most times you see x appearing in any one denominator is once. So what I've done now is I've listed each different factor the greatest number of times it's appeared. The 2's appeared 3 times here and only once here, but I take the greatest number, which is 3 times. The 5 only appeared once, and the x only appeared once. We can now move on to step number 3. And step number 3 says, now let's go ahead and let's multiply the denominator factors from step 2 to get our LCD. In other words, we'll simply take these numbers right here and make it a product and multiply it out. 2 times 2 times 2 is 8, times 5 is 40, x. So we multiplied out these right here and got our least common denominator. And so to summarize, let's go back to the top. The least common denominator of 1/8 and 3 over 10x is 40x. That's the least common denominator. That's the smallest thing that both 8 and 10x will divide into. Okay, so keep those steps handy. I hope you copied them down, and we're going to work several examples now. Okay, so let's do example B. And for example B, I have the following two fractions. I want to find the least common denominator of 8a squared b cubed. Let me zoom in a little bit so you can see that better. So that's 3 over 8a squared b cubed and 5 over 12 a to the 5th b cubed. I want my least common denominator. So what I want to do now is I want to take each denominator and put it into prime factors. 8a squared b cubed, 12a to the 5th b cubed. We're going to put them into prime factors. 8 is 2 times 2 times 2. A squared is a times a. And b cubed is b times b times b. 12 is 2 times 2 times 3, right? 4 times 3. And then you have 5 a's. 1, 2, 3, 4, 5 a's. And 3 b's again. Okay? Now, take the greatest number of times each factor occurs. We'll start with the 2's. 3 2's versus 2 2's. The most the 2's occur is 3 times. So we'll put 3 2's. Let's go to the number 3. 3 appears once here and not here, so the most the 3 appears is once. And let's go to the a's. 2 a's versus 5 a's. Well, clearly 5 a's is more than 2 a's, so we're going to list 5 a's. And 3 b's in both cases, so 3 b's is the most the b's occurred. Multiplying this out, you get 8 times 3, which is 24, a to the 5th, b squared, b cubed. Sorry about that, because there's 3 b's. And that is the least common denominator. Now this might look a little confusing, and you can often do this by just simply doing these in your head. If you take 8 and 12, and you were looking for the smallest number that both 8 and 12 divide into, you could figure out the first number they both divide into is 24, and you don't have to list out all the prime factors. Same thing with a squared and a to the 5th and b cubed and b cubed. Just looking here, you take the most number of times your a appears, which is 5 times, so you have a to the 5th. And the most number of times your b appears, which is 3 times, so you have b cubed. So that's 24 a to the 5th b cubed. Okay, let's now look at the next problem, example C, which is find the least common denominator of the following two rational expressions. We have 6 over x squared minus 4x and 3x minus 1 over x squared minus 16. So we have 6 over x squared minus 4x and 3x minus 1 over x squared minus 16. Take your denominators. You have x squared minus 4x, and then you have x squared minus 16. Now this is a little different. Let's find the least common denominator here. As always, the key is factor first. Whenever you're dealing with complicated rational expressions, factor first. So let's factor. Take out an x, and you're left with x minus 4. And that's as far as that one will factor. And down here, this is a difference of squares, so it factors as x minus 4 times x plus 4. So now let's get our least common denominator. Our least common denominator is now a product of the factors that appears. Let's start with x. X appears once here and no times here, so that means we write 1x. X minus 4, it appears once here and once here, so the most that x minus 4 appears is also once. And x plus 4 does not appear here but appears here once, The most x plus 4 appears as once as well. And so the least common denominator for these two rational expressions is x times x minus 4 times x plus 4. And again, the key was you had to take those denominators, factor them first, and then list the most any one factor occurs in each denominator. Okay, let's take a look at example D then, the last example for least common denominators. So example D says the following. Find the least common denominator of 3x over x minus 1 quantity squared and x minus 4 over x squared minus 1. So let's list our denominators. The first one is x minus 1 squared. And the second one is x squared minus 1. They look kind of similar. The only difference is where the 2, the exponent 2, is placed. Well, the first one is already factored because x minus 1 squared is simply x minus 1 times x minus 1. So I'm just going to list it like that. X squared minus 1, however, this is a difference of squares, and that factors as x minus 1 times x plus 1. So now let's get our least common denominator. You have two factors to worry about, x minus 1 and x plus 1. X minus 1 appears once here, but it appears twice here. The greatest number of times x minus 1 appears is twice, so you have to include it twice. X minus 1, x minus 1. The x plus 1 doesn't appear here, but appears here once, and so you only have to put one x plus 1 down. So the least common denominator for these two right here is going to be x minus 1 twice times x plus 1. Again, because it appears twice here in the first factorization. Okay. One other thing that's going to be important when we do addition and subtraction of rational expressions is we're going to want to be able to convert from denominators to new denominators. So that's actually the next thing I want to take some time doing. So let's look at Elmo again, and let's do rewriting rational expressions to have new denominators. Rewriting rational expressions to have new denominators. Our first example, A, is 5t squared over 3y equals what over 9y squared? You want to convert this fraction to this fraction. To do this, you have to ask yourself, 3y times what gives me 9y squared? Well, 3y times 3y would give me 9y squared. If you multiply the bottom by 3y, well then the rule is that you also have to multiply the top by 3y, just like when converting regular fractions. So the top becomes 15t squared y, right? 15t squared y, and therefore that is the new numerator. Okay? So again, you look here, what times this gives you this, repeat it to the numerator, and then multiply. Let's look at example B. Example B says negative 7y over 6y plus 18 equals 24y plus 72, or equals what over 24y plus 72? You've got some rational expressions, so the first thing we do is factor. So let's factor these two denominators, and when I do that, I get 6 times y plus 3, and over here I can take out a 24, and you're left with y plus 3. And notice how simple this problem has become. What do I need to multiply by here to get me 24y plus 3? Well, I already have 6 times y plus 3. The only thing I need to multiply by here is 4, right? I'm going to have to multiply 4. 4 times 6 would give me the 24. So now let's multiply on the top by 4. 4 times negative 7y, that gives me negative 28y. And therefore, that is the new denominator that you need. So again, when you have these rational expressions, you want to factor first. Okay? So let's look at example C then. Example C says let's take 4m over m squared minus 8m plus 15. And I want to know that's equal to what over m minus 5 times m minus 3 times m plus 2. Again, factor first. This is simply 4m over m minus 3 times m minus 5. And you want that to equal m minus 5 times m minus 3 times m plus 2 as your denominator. Okay? Well, this isn't hard at all. M minus 3, m minus 5, you've already got m minus 3 and m minus 5. The only term that's missing here is the m plus 2, so you're going to multiply times m plus 2. If you do it to the denominator, you also have to multiply on the numerator. So you have 4m times m plus 2 being your new numerator. Or, if you like, we can multiply this out. This is equivalent to 4m squared plus 8m over m minus 5 times m minus 3 times m plus 2. Okay, so this one or this one, they're both the same. Here it's just factored, here it's not. So, just to repeat and just to summarize, whenever you're working with rational expressions, you always factor first. We're going to next look at section 6.4 in the next video, which is the last video, yay, for the algebra course. And so what you're going to need to be able to do is you're going to need to be able to find the least common denominator, and you're going to need to be able to convert fractions to new denominators. So, until next time, practice, and then I will see you with section 6.4. Bye.